a measure of concentration, and concentration is the amount of solute per quantity of a solution. There are lots of ways actually to measure concentration. You could have grams per liter, you can have grams per kilogram, which gets into some weird stuff. You can have percentages, but for the sake of chemistry, we focus on molarity. Molarity is the amount of solute in moles per volume of solution in liters, which gets into some nice stuff where we can use this in stoichiometry. We'll talk about that in a minute. And a reminder that if you're trying to find moles, you've got to do your mass divided by your molar mass, because we won't always be able to give you moles. This gets back to what we talked about with stoichiometry. We have to still use mass in chemistry because we have balances that can measure mass. There's not a balance in the world that you can be like, I need 0.5 moles of sodium chloride, and it'll actually weigh that out. You've got to weigh a mass of sodium chloride and then make sure that's the right number of moles. And as a friendly reminder, because this will come up, 1 liter is 1,000 milliliters. You have to have liters to do your molarity, but more often than not, we're not going to be in liter kind of quantities. We're going to be in milliliter kind of quantities because liters are big and we try not to use that much stuff in chemistry if we can avoid it. So to calculate a molarity at its most basic, find the molarity of a solution made by dissolving 0.335 moles of ammonium sulfate in 600 milliliters of solution. So the moles are easy. We know molarity is equal to moles over liters. So I'll put my moles up here. But they didn't give me liters. They gave me milliliters. Remember, to go from milliliters to liters, we're going to move our decimal to the left 3 places. So the decimal comes from here to 1, 2, 3 places over. So this is going to be my new decimal. And so this is now in liters. So I put that down here, 0.60. Remember, the zeros after don't actually matter. So then all I've got to do is 0.335 moles divided by 0.6 liters, and that's going to get me 0.558. Remember, it's usually safest if it's less than 1 to keep 3 decimal places. So my molarity is going to be 0.558 molar. We usually pronounce big M as molar, but that's just molarity. All right, let's look at our next one. So this is a slightly more complicated problem, and this is what I warned you would happen. We aren't always just going to be given moles. Sometimes we're going to be given grams. So first thing, remember the cardinal rule of chemistry is if you're not given grams, you're going to have to get there. So we're going to calculate the concentration if we've got 45 grams of ammonia and 0.75 liters of solution. So at least this part there were nice. So we're going to start with we've got to convert my 45 grams of NH3 into moles. Remember, if I've got grams up here, I need grams down here. Those grams are going to come from the periodic table. If we look at the periodic table, we add up nitrogen, which is 14.007, and 3 hydrogens, which is 1.008. So this should work us out to about 17.04 grams of NH3 for every 1 mole of NH3. So now we can do our math. I should move this so I can see both at the same time. Sorry about that. So I've got what ends up being 45 divided by 17.04. And so that gets me a number of moles, which is 2.64 moles of NH3. So that's my moles. Now I know my moles and I know my liters. So now I can plug it in down here. 2.64 moles divided by the 0.75 liters they gave me. And so we're going to divide that by 0.75. And so now I get a molarity of 3.52. So remember, if you're trying to find molarity, it has to be moles, so get to moles if you're not there. So now we're going to look at how we use molarity to do dimensional analysis, which means we can also use it in stoichiometry. We're not going to quite get there yet, but we'll look at how to use it in dimensional analysis. We can find things other than concentration. So first problem here is, what mass of sodium nitrate is present in 0.4 liters of a 0.735 molar solution? So remember, we've been talking about molarity, capital M, means moles per liter. And that's important because remember when we started talking about dimensional analysis, we told you that if you've got to pick between two numbers and one has 1 unit and one has 2 units, you want to start with one that only has 1 unit. Capital M is really 2 units, even though it looks like 1. So given the choice here, we want to start with our 0.4 liters. So I'll put 0.4 liters of sodium nitrate. We know if I've got liters up here, I need liters down here, and that's what I just talked about. I know my moles per liter. Remember, if there's not a number, it's 1. So for every 1 liter of solution, I know I've got 0.735 moles of sodium nitrate, because that's the definition of molarity. So I got to moles, and we should know by now, if I know my moles of a substance, then I can find my grams of a substance by using the periodic table. So we know that for every 1 mole of sodium nitrate, I get a mass equal to the mass from the periodic table. So that mass is going to be 22.99, my mass of sodium, plus 14.01, my mass of nitrogen, plus 3 times my oxygen, which really is 16. So that gives me a total mass of 85 grams of sodium nitrate per 1 mole. So now I just got to do my math. So all of my numbers that aren't 1 ended up on top. So now I just need to multiply. So I've got 0.4 times 0.735 times 85, not 88. There you go, 85, for a total mass of 24.99 grams of sodium. That is not the button I was trying to hit there, sorry. Sodium nitrate. Technical difficulties. Not so bad. Molarity is just a new thing we can use for moles. This again is one of those weird cases where our moles is not 1. Our liters are 1 because our number is not here. My number is next to my moles, so my number stays with my moles. Be careful with that. All right, now what volume in milliliters of a 3.52 molar solution would contain 20 grams of sodium hydroxide? Again, when you see capital M, think moles per liter. To remind yourself, it's got 2 units, not 1. We don't want to start our dimensional analysis or stoichiometry there. So we want to start with our 20 grams of sodium hydroxide, because grams is a single unit. And I know that if I've got grams here, I need grams down here. And I also know that if I'm not in moles, it's a good bet I have to get there. So I need my grams from the periodic table here. And one of the reasons I use sodium hydroxide for this problem, you add up all your masses, molar mass of sodium hydroxide ends up being exactly 40. So so you got 40 grams of sodium hydroxide for every 1 mole of sodium hydroxide. This is a unit 6 problem. We've been doing this for a long time. Now I get to the new bit. Now I know my molarity is moles per liter. So to get from moles to volume, I'm going to use this. So moles are here. I need moles down here. Remember, my number is with my moles, so it stays with my moles. So 3.52 moles of sodium hydroxide for every 1 liter of my sodium hydroxide solution. But if I look at this question, it didn't want liters, it wants milliliters. So the reminder I gave you at the beginning is that for every 1 liter of anything I have 1,000 milliliters. So now I do my math. Remember, we're going to multiply everything on top. So I've got 20 times 1 times 1 times 1,000. I don't actually worry about my ones because they don't affect my math. So it means up top I've got 20,000, and then I'm going to divide by 40 and divide by 3.52. You could also use parentheses, multiply those, but as long as you're dividing by the things underneath, you're good. Whatever works best for you and your calculator. So I find out my final answer is I need 142.05 milliliters of my sodium hydroxide solution to get 20 grams of sodium hydroxide. All right, so not a whole lot new in this. Remember, your molarity is always moles per liter, and then that's important when we're doing dimensional analysis. So at this point, you should be able to do your next set of notes, which is about diluting solutions, which is going to work a little bit differently, but cover some of the same things. So do that set of notes next before you try and do your quest, because the quest is going to ask you to do both.